All right, so in this video, I'll be talking through pages 30 and 31 in the notes packet. We just did arithmetic series, so now we're going to do the flip side, geometric series. So we have example 1, where we're taking the sum of each term in this geometric sequence. So the sum of the first term is 5, the sum of the first two terms is 15, then we add 30 and we get 35, then we get 75, and we get 155. How could we find the sum of the first 10 terms? Well, we could continue on with this pattern, right? We would need to find every term between u1 and u10 and add them all up, and no one has time for that. So instead, we're going to use this formula. So you have the formula Sn is equal to u1 times r to the n minus 1 divided by r minus 1. And the good news about this formula, see with arithmetic sequences, we needed to find un, right? We had a un in our formula. Here we don't have a un, right? We only need to know u1, r, and n, and we're good to go. Here the hardest part is just plugging it into the calculator. So let's find S10. So we're trying to find S10. We know u1 here is 5. We know that our common ratio is 2. And we know that n is 10. So if we take our Sn, our formula, and we try and find S10, well, it's going to be our common ratio, or sorry, our first term, which is 5, times our common ratio to the nth power, so it's times 2 to the 10th, minus 1. All of that over our common ratio 2, minus 1. So if we plug that into the calculator, we have in our numerator 5 times 2 to the 10th minus 1, and then all of that divided by 2 minus 1. And I recommend you put it in like this. Notice how I have one set of parentheses around the entire numerator, with the subtraction in a second set of parentheses divided by a final set of parentheses. All right, that way it's very clear we're taking 5 times what we're times 2 to the 10th, and then we're just dividing that by 2 minus 1, and we get 5,115. So 5,115. All right, geometric sequence has all its terms positive. The first term is 7, and the third term is 28. Find the common ratio of the first 14 terms. So here we know u1 is 7. We know that n is going to be 14. So all we need is n, which we need to solve for using our formula. So we have un is equal to u1. Sorry, so I can do it this way. So un is 28, right? Un, that's 28, is equal to u1, which is 7, times our common ratio, which is what we want to find, r, to the n minus 1, and we know n is 14. So it's going to be 14 minus 1. So that means 28 is equal to 7 times r to the 13th power. We divide where did 14 come from? Oh, I see. Nope, so here n is not 14. N is, oh, so n will be 14 there. All right, mulligan. Start the whole thing over. So before we start talking about the series, we need to find our common ratio, right? Let's start with A alone. And for this, we're going to use this formula down here. So we know that U3 is equal to U1 times R to the 3 minus 1, right? And so that means U3 is 28. U1 is 7. We don't know R, and that's squared. Can divide both sides by 7, and we get 4 is equal to r squared, which means r is equal to 2. R could also be negative 2, but we see here all of its terms are positive. So r has to be positive 2. All right, so if r is positive 2, then we have everything we need to solve b. where we're just going to use our formula up here. So U1 is 7 times our common ratio 2 to the 14th power minus 1, all of that over r minus 1. So all of that over 2 minus 1. Right, and this is S14. That's the sum of the first 14 terms in the sequence. So 7 times 2 to the 14th minus 1, and then all of that divided by 2 minus 1, like that. And we get 114,800 All right. So we go on to example 3. So here, this is an example where we know UN, but we need to find N in our formula. So here, we know that UN is going to be equal to, so if we know UN is equal to U1 times R to the N minus 1, well, then that means this here, which is our UN, 4,952, or 49,152, is equal to U1, 3, times our common ratio, which we see is 4, right? Because 3, 12, 12, 48, multiplying by 4 each time, to the N minus 1. So the first thing you want to do is, I'm just going to do this one using the calculator. So we can go y equals, y1, we'll put 3 times 4 to the x minus 1. And make sure to delete this and delete that. And then just get rid of everything I was doing. 3 times 4 to the x minus 1. All right, and then here we're going to put 49,152. And then we can go second trace, intersect. We see that in this case, N is going to be 8. So N equals 8. Okay. All right, so now that we know that N is 8, what we're going to do, we're going to take our formula over here. So we know that S8, the sum of the first 8 terms in the series, is going to be U1 times R, which is 4 to the 8th minus 1, and all of that over R minus 1. So all of that over 4 minus 1. All right, and we can go over here, second mode. We can go 3 times parentheses 4 to the 8th minus 1 divided by 4 minus 1. We hit enter and we see that's 65,535. All right. And then I don't know why this is here. We've already covered this, but just to review it, if you want to increase rent by 6%, you need to multiply by 1.06. If you want to decrease it, you multiply it by 0.94. All right, but you can mostly just ignore that. That's just reminding us of how the percent changes, how they get translated into common ratio. All right, so example 4. An author published a book which was being sold online. The first month, the author sold 27,500 books, but the sales were declining steadily at 10% each month, if this trend continues, how many books would the author have sold over the first 6 months? All right, round to the nearest whole number. So here we have U1 equal to 27,500. R is going to be 1.10. I guess a 10% increase. And N is going to be 6. So that means S6 is equal to 27,500 times 1.10 to the 6th minus 1 over 1.10 minus 1. All right, if we go here, you get 27,500 times 1.1 to the 6th minus 1 divided by 1.1 minus 1. Enter. And then we get 212,179. So 212,179. That's S6.